In this lesson, we'll talk about how to start a complex part. After completing this lesson, you'll be able to create construction geometry. With our battery keep-out sketch in place, we can make sure that we're currently dealing with an active component, so any new sketches that we create will be placed inside of it, and we can start to lay out the sketches for the overall shape of our design. Now you might be wondering why we don't have more keep-out sketches. Most of the components are quite a bit smaller than the batteries. The batteries are not only the greatest in terms of the amount of mass that they add to the overall design, but they also have the biggest size. Things like the power distribution board, or the receiver from the transmitter, or the camera itself are all quite a bit smaller. Most of those components are actually going to be stacked on top of the batteries. Not necessarily directly, but in terms of how everything is going to be mounted. We're going to have our power distribution board on top. We're going to have our flight controller directly centered on the origin, and it's going to be on top of everything. And we're also going to be able to place our receiver from the controller. Also, our camera is going to be located on the front of the device, and the transmit antenna will be on the back. So all these various components, including the speed controllers, are all going to be stacked in a way where they're not really going to be affecting the performance of the overall quadcopter. Now, things like the motor and the propeller, those are obviously pretty critical components in terms of their mass, but they are going to be at a fixed location. We're not going to be moving them around. Everything else does have mass, but it's quite a bit smaller than the batteries. So we are free to sort of move them forward or backward to make sure that they're not obstructing any airflow or in the way of the propellers. So that's why we're really just focused on the batteries. Now, ideally, if you knew exactly which battery you wanted, you would just draw both of those on left and right. You would create a mirror. But in terms of my design, I want to make sure that I account for both of those. So now that we have the battery keep-out sketch, I'm going to rotate a little bit, and I want to create a sketch on the front plane. So again, I like to start my sketches by selecting the new sketch, and it gives me a good idea of the plane I'm dealing with. If you're ever curious about the plane, when you hover over it, you notice that it highlights it in the browser. So we're dealing with plane XY. And if you look at the view cube, you can see that we're also dealing with the front plane when we select XY. So that can sometimes help. So for this front sketch, what I want to do is I want to create the shape of the new drone from the front. Now this is not the full solid shape because obviously it's going to be a very complicated part, but I'm going to create a reference surface that's going to give me the top shape. Now we're keeping this fairly simplified because we want to make sure that we explore a lot of creative geometry. We want to make sure that we learn a lot of the advanced tools as well as how to apply some of the basic tools. So you don't necessarily have to 100% follow along with what I'm doing, but it's a good idea, especially if you're new to Fusion and you're new to designing, that you follow pretty closely along with what I'm doing so that you don't get too far away from the original core aspects that we're trying to learn. So the first thing that I want to do is start a line. And again, you have many options for how you can get these tools. You can use the marking menu. You can go to the sketch option. And once you're on the sketch option here, you can go directly to the line tool, which is at the 6 o'clock position. So if you want to do this fast, you just hold down the right mouse button and drag straight down, and you're on the line tool. You can also hit L on the keyboard to hit the line tool, or you can use it directly from the top toolbar. All right, so again, I like to access these with quick keys or various ways. So I'm going to use the marking menu to access my line tool, start at the origin, and I'm going to draw a line vertically. I'm going to click, and then I'm going to hit the green check mark. I want to hit escape to get off of that line tool, and I want to take a look at something. It automatically applied a vertical constraint for me, but the line is still free to float around. There are two things that I need to do with this. First, I need to select the line by left clicking, and then I'm going to make this a construction line. It's only there for reference. The next thing I want to do is press D on the keyboard, and I want to dimension this line. And this one's going to be 76.2 millimeters, and then I'm going to zoom out. Go ahead and draw one more line. This one is going to be from the point at the top to the left, but I want to make a note here. So we made this a construction line after the fact. If you know that you're going to be sketching construction lines, you can turn the construction option on, and then everything you sketch will automatically be a construction line. Just remember to turn it back off when you want to create normal geometry. This line does not need a dimension It's only here for a tangency reference. But notice that it automatically applied a perpendicular constraint. So now we have perpendicular constraint, the points are coincident, and I have a vertical reference here. You might be wondering where 76.2 millimeters came from. Well, if you remember from our design criteria, we wanted to keep the entire device as low profile as possible. Most of the camera drones on the market are relatively tall for additional flight stability, but we're looking for making an extremely agile craft, but we wanted to keep it as low as possible. So 76.2 millimeters is 3 inches, and 3 inches is sort of a criteria that I gave that I want to try to fit into. Now, of course, we could make it taller or smaller as needed, but 3 inches will give us a pretty good margin of error in terms of keeping enough air above and below the props, so that way we don't have any restrictions or prop wash or any weird oscillations when we're trying to take off. So that's the starting point, and that's where that 76.2 came from. Again, when you start these designs, sometimes you have to give yourself artificial criteria and see how things fit. And if we find out that 76.2 is too much or not enough, we can always come back to this sketch and adjust it, and everything else will be based off of that number. So as we look at this, 76.2, this is our starting point for the center line of our front shape. So we're going to create an arc by going up to Sketch, and we're going to create a tangent arc. Now the reason we're going to create a tangent arc is because we're going to carry tangency from this horizontal line, and we're going to carry it out to the right. Now if you like to design out to the left, that's perfectly fine. I prefer to design out to the right. So I'm going to be starting from here and simply drag that out and then hit Escape. Automatically have tangency applied because of the type of arc that we used. And now there are 2 more dimensions that we need to apply to this. So D on the keyboard, we're going to go from this endpoint, from the origin, or from this vertical line. Either one is going to be fine. And we want to place a horizontal dimension of 200 millimeters. Then we want to give this a radius value of 500 millimeters. Now again, you might be wondering where these numbers actually came from. The 200 millimeters is because I want to fit within a certain constrained overall size. Now remember, we're dealing with half of the shape here. So from the front, we have 200 millimeters wide, and it's going to be wider than our overall design. And the radius value is just approximately what looks okay. We want a little bit of curve because we're dealing with a 3D printed plastic part. If we print it flat, it's not going to be very strong. That little bit of curvature is going to give us some extra strength, some extra structure. So the 500 doesn't really matter here. It could be more, it could be less. It really just gives us a little bit of rigidity to the overall design. Now, if you make that number smaller, you could push the motor up higher and not have to worry as much about prop clearance. If you make the number smaller, you're going to have more curvature there, and then you're actually going to restrict where the propellers can go because you're going to start to run into issues where the propeller might hit the design. So again, somewhat arbitrary numbers, just making sure that they're visually okay and making sure that that 200 is bigger than what we want to design, because ultimately we're going to trim this back. So let's go ahead and stop the sketch. And again, I want to rename this sketch, and I'm going to call this front profile. Let's go ahead and save our design. And if you want to add a version description, this will be visible on Fusion Team. But for right now, I'm going to leave user saved and just say OK, so we can start to add some more sketches.